The flow units are million liters per day. That's not a very usual format for flow rate, so I'm going to change it to meter cubes per day, and there you go. Instead of 97.4, I have 97,000 cubic meters per day. I'm going to stand on the first cell, and with the right mouse I'm going to click, and I'm going to go copy. Then I'm going to open Excel. I'm going to open any workbook. I'm working on a Mac, so if it looks somewhat different, don't be concerned. It's just the format of this Mac Pro. But I opened a white page workbook of Excel, and I'm going to go with the right mouse, click, paste, and what you see there, I'm going to expand it to 200% so you can see, is basically what was contained in the influent dynamic data of the process that was shown in the BioWin configuration on the previous screen. So basically you have time in hours, and I guess it's, yes, it's 24 hours from 0 to 23, flow rate in cubic meters per day, COD, and the rest of the parameters. Now, let's assume for a moment that these values that we have here come from historical data information from an existing real plant, and that I want to bring them into BioWin to run a simulation. So what I would do then is, assuming that the parameters are organized in the format that BioWin has them listed, I'm just going to copy them, just the numbers, not the names, and I'm going to go select all the area. I'm going to go right click, copy, and now I'm not going to copy them on the same layout from where I took them out. So I'm going to close this layout, and I'm going to open one that I know does not have dynamic information, which is this one, anaerobic digester. So I'm not going to save the changes to the current project. I'm going to save this anaerobic digester because it was actually created in an old BioWin format. I'm going to say yes. I'm going to close. And now that I saved this and that I have a good layout of a conventional plant for BNR, I'm going to go into influent. Let me put it a little bigger so you can see. That's the influent, and if you see the black line there, it means that that is running at steady state. Maybe because it doesn't have dynamic data, which I know it doesn't. So I double click here. I'm going to go and select variables. So I'm switching from constant conditions to variable conditions, and I'm going to go edit data. As I suspected, there's no data populating all the times for this dynamic simulation, so I'm going to stand here on time. I'm going to click with the right click on the mouse, and I'm going to go paste, and here I have all the data that I had from this quote-unquote real plant in the Excel spreadsheet, pasted and copied onto my new plant in a way that I could do and run dynamic simulations with it. Couple of words of caution: if I do not have my historical data in the Excel in the same order that is here required by BioWin, I have two options. One, I can rearrange it in Excel and then copy it and paste it onto BioWin, or if I do not want to rearrange the Excel because it's a complicated graph or table or for whatever reason, I can just copy columns. The second word of caution is that when I copy column by column, or if I copy the whole matrix as I just did, I have to make sure that the units are correct, are matching. So the time, if I have it in Excel in hours, here it has to be marked in hours. If I put hours into days, it's going to interpret days, and you know the drill. Same thing for the flow. If I have marked here that is in cubic meters per day, as I do, I cannot put million liters per day or megagallons per day and assume that BioWin is going to guess the unit. So that's a very typical mistake. Just make sure you don't do it. So what I have done is I've taken data from BioWin and pasted it onto Excel, and I have taken data out of Excel and pasted it onto BioWin. But Some of the interesting things about pasting data from BioWin into Excel is not really getting the influent data, which probably came in originally from an Excel spreadsheet, but getting effluent and time series data from results from the model into Excel in a way that I can later on use them, manipulate them, do calculations that Excel allows me to do. So what I'm going to show you, opening again that layout of the MLE process, is how to do that. So I'm opening that layout. I'm not going to save changes to this large plant with digester, and I'm just going to open my simple BNR plant. And if I go Control A to open the album, I'm going to see that this has been run already. So I have populated tables that I have prepared. I'm going to put them a bit larger so you can see what you have. You have influent data. You have different types of graphs. Now, any of these graphs that we have here, for instance, the dynamic chart in the effluent, showing ammonia nitrogen and nitrate nitrogen in the effluent, can be copied onto as a figure onto Excel. So I just click here with the right mouse, I go chart, I go copy, and if I open Excel and go to a new sheet, I can do it on the same sheet, but just to keep things tidy, I'm going to open a new sheet, and I stand on any cell I want to, and I go with the right mouse and put paste. I will have here the graph I have just copied from BioWin. Now, this is a graph that has a sort of like a picture format, a JPEG or something equivalent to that. So basically, I cannot come in here and use any of these values. But it's a good approach to show information if you want to, or copy them onto Word or other documents that you may want to use. Another way to pass data of results in the effluent or other parts of the plant to Excel would be to, in this case I'm not going to save this, would be to tell the system to monitor the data I'm interested in. And so how do I monitor data that I'm interested in getting the time series and putting onto Excel or another software? Well, I double click on the icon where the data I'm interested in monitoring is located. This is one of the several ways to do it. This is the one I use. I double click on the effluent. Generally, these icons have physical and operating conditions and monitoring conditions. This one, since it doesn't have any physical or operational conditions, being an effluent icon, we only have the monitoring values. And as you can see here, I have checked volatile suspended solids to be monitored, total suspended solids, total COD. I can add some if you wanted. I can add filtered TKN. And here on the state variables, I have added ammonia, nitrate, flow rate, and I can put pH as well if I wanted to, and I go OK. Then the next stage, I mean, you can do it also for other parts. If I go here into the anoxic one, you see it's going to have dimensions, it's going to have operation, you're familiar with that. It's going to have monitor items, which is in this case the last one. And I have checked already total suspended solids and volatile suspended solids, but you can check other things. You can check soluble phosphate for instance, and go OK. And now I'm going to go into project, and I'm going to tell the system in database to export this set of values that I want to monitor onto a file. And the file can be a text file or can be a comma separated file. Both can be read by Excel. I'm just going to go comma separated because I'm more familiar with that. I have already one there. I'm going to use one like UCI course test data. And I'm going to save it. It tells me here a list of all the things, all the data that is being saved. Notice that these effluent filter TKN and pH were just incorporated in the last clicks I did. If I close like this, I can go Control A, open the graph. I don't need to do this. I could just run the simulation, but I'm going to run the simulation with the graph on since it's a bit more entertaining. So I'm going to go, I press dynamic here. I'm going to press play, and I'm going to let the system simulate from current values for 2 days. I'm going to go start, and the simulation would run in this MLE process in which I have dynamic conditions in the infant, as you saw. Is going to finish the simulation, and all this information that is here is going to be recorded within a time interval that I could predefine. I'm not going to get you into that, but I recommend you go into the manual if you don't like the default time interval. In this case, it's 1 hour. I'm going to close the graph. I'm going to save this, and then I'm going to go open Excel and go File, open a new file, and I'm going to say that the new file is in desktop because basically I'm looking for this file here, UCI course test data dot comma separated values, and in order to find it, here it has to say all files. If I open it and I put all Excel files, this is going to be hidden. So I wanted to put all files, and I'm going to open UCI test data. I'm going to open it up, and there you go. You have the values. Some of them are showing ones. I think it has to do with a glitch that I did not close the BioWin. I can try again, or probably I didn't give enough time to save. But I'm going to go, or maybe there's no anoxic value there. I have to check into that. But if you go here, I'm going to open this larger. And if I go here to time and days, the time and days is set up in an Excel format. So this would be the date of the day I started simulating. If I put this column in a format that is dates, it will show me what date it is. For instance, these are run on, you know, I think it's January the 8th. 2017, I suppose. I'm not sure what format it has. I'm going to change the format again until I get one that I like. For instance, this is more complete. It gives me the whole, or maybe this one is clearer. I'm going to go OK. All right. So January 8th, 2017. I don't know why I picked that date, but the thing you want to put here is you want to put it in hours. So I'm going to format cells. I'm going to put this in time, not date. I'm going to put it in hours, whichever format of hours you feel comfortable with. I feel comfortable in 24-hour format. I'm going to go OK, and there you go. You have it in 24 hours, every hour. Some go into, for instance, here 1959 minutes, but that is simply because